Hello, and welcome to this video on gravitational potential energy for GCSE Physics and Combined Physics. And don't forget to like and subscribe. Gravitational potential energy is the name given to the store of energy that objects have if they have mass and are in a gravitational field. As an object is lifted, energy is transferred into the gravitational potential store and the store increases. As the object falls, energy is transferred from the store and the store decreases. In this system, the ball is falling. As it falls, because gravity is acting on it, its height decreases and so its gravitational potential store decreases. The energy does go into a different store. It's still accounted for, but we are concentrating only on gravitational potential energy for this video. Gravitational potential energy is also affected by the mass of an object. The larger the mass, the larger the store of gravitational potential energy. Mass is the amount of matter a thing is made of. It is measured in kilograms. In the system of the dropped ball, if we replace the ball with one that has more mass, it starts with a greater amount of energy in its gravitational potential store. It then loses this energy as it falls. In this example, the ball is gaining height. As it does so, energy is being transferred into its gravitational potential store. The greater the height, the more energy is stored in the ball's gravitational potential store. The last factor that is involved in gravitational potential energy is the gravitational field strength. The stronger the gravitational field is, the bigger the gravitational potential energy store will be for the same object, so the same mass, at the same height. Gravitational field strength increases with the mass of the object. For example, a larger planet will have a larger gravitational field strength. A 1 kilogram object at a height of 1 metre above the surface of the Earth will have a lower gravitational potential store than when the same object is 1 metre above the surface of Jupiter, and that's because Jupiter has a much larger gravitational field strength. This isn't to scale, but you get the idea that Jupiter is a lot bigger than the Earth. As we have seen, gravitational potential energy of an object depends on its height and its mass and the gravitational field strength. The higher the object, the greater the gravitational potential energy, and the larger the mass, the greater the gravitational potential energy, and the larger the gravitational field strength, the larger the gravitational potential energy. The relationship between these variables is as follows. Gravitational potential energy equals the mass times the gravitational field strength times the height. Or in symbols, E subscript P, which is gravitational potential energy, equals mgh. Mass times gravitational field strength times height. The units are as follows. Gravitational potential energy is in joules, mass is in kilograms, gravitational field strength is in newtons per kilogram, and the height is in metres. In the next video, we will look at how this equation is used. Bye for now, and thank you so much for listening.